OP is trying to solve the quadratic equation z squared minus 5 1 plus iz plus 13i equals 0. He thinks that 2 plus 3i is a zero of this equation. We want to show that he is correct. Now we can do that just by substituting 2 plus 3i for z. So we'll get 2 plus 3i squared, take away 5, 1 plus I, 2 plus 3i, plus 13i. So expanding out, that's going to give me 4 plus 12i plus 9i squared, take away 5, 2, and then we'll get plus 3i plus 2i, so plus 5i, plus 3i squared, plus 13i. So I squared is negative 1, so we're going to have 4 take away 9, which is negative 5, plus 12i, take away 5. Again, I squared is negative 1, so 2 take away 3 is negative 1, plus 5i, plus 13i, which is negative 5 plus 12i, plus 5, take away 25i, plus 13i, and clearly the negative 5 and the positive 5 here are going to cancel, and the 12 and the 13 will cancel with the negative 25, and so that is equal to 0, and therefore OP is correct. Josie says to OP that if 2 plus 3i is a zero of the equation, so is 2 minus 3i. Is Josie correct? Well, no. And explain that only is true that you get roots in conjugate pairs if all of the coefficients are real. And here we have a complex coefficient. Therefore, that's not true. Note that we also have a purely imaginary constant term. Either of those things would invalidate this statement about the conjugate pairs, and in this case, both of them are present. So now we're given a cubic function which does have all real coefficients and a real constant term as well. We're told that 1 plus 2i is a solution, and we want to find the values of a and b, where a and b are real. So that's how I knew all the coefficients were real. And that means that 1 minus 2i is also a solution. We have all real coefficients, then any complex solutions occur in conjugate pairs. That means that z take away 1 plus 2i, z take away 1 minus 2i would be a factor. So let's expand that out. We get z squared minus 2z, because when you do the cross terms like this, you get a plus 2i there and a minus 2i over there, which means you end up with just the negative 2. And then we'd have plus 1 plus 2i, 1 minus 2i, and by dots, that's just going to be 1 plus 4. So that's going to be plus 5. And so what we must have is some linear factor, which would be z minus p, say, and then z squared minus 2z plus 5. Now I've chosen the z at the start of this because we just have a z cubed here, and the z times the z squared would give me the z cubed. And then we could just look at this end. We've got negative 25. This is a positive 5. So it would stand to reason that p is equal to 5. So what we have is z minus 5, z squared minus 2z plus 5. And so expanding that is going to give me z cubed minus 2z squared plus 5z minus 5z squared plus 10z, take away 25, which is z cubed minus 7z squared plus 15z, take away 25. And so we can see that a is equal to negative 7 and that b is equal to 15.